Alright, in this video we'll be working out the area and perimeter of sectors, and we'll start with the area of this guy, which I'm just going to write down in the top left corner is pi times 5 squared times 1/4. Now why would it be that? I guess if you imagine the rest of the circle, you'll find that our piece actually is exactly 1/4 of the circle. And so the pi times 5 squared is the area of the whole circle, pi times radius square, and we're timesing by 1/4 because we don't have the whole circle, we've only got 1/4 of it, right? And so we've got to multiply by 1/4 to allow for that. Okay. Now, what makes it 1/4 of the circle, I think, is the fact that the angle in the middle is a 90-degree angle. But what we want to be able to do is to work out the area of a sector that's not just a nice angle like 90 or 180. We want to be able to work out its area no matter how big or how small that angle gets, even if it's some random thing like, say, 50 degrees. Okay, so let's look at the area of this 50-degree sector here. Now, what's the meaning of 50? What it means is if you look at the top left corner, we don't have 1/4 of the circle anymore, right? That's now wrong. Okay, what we have now, it's not 1/4, it's less than 1/4. What we have is only 50 degrees out of the full circle. So we have 50 out of the full circle. Now, what's the angle of a full circle? It's out of 360. And so that's why the fraction is no longer 1/4. The fraction will be 50 out of 360 instead. Okay, so that's now how much of the full circle we've got, and so we can now work that out to be 10.91. Okay? Now, in general then, if we have a sector with a radius r and an angle of theta, the area will be this formula here, pi r squared multiplied by theta over 360 degrees. Now, the reason for that, okay, is because pi r squared gives you the area of the whole circle, and the theta over 360 gives you what fraction of the circle you've got. Okay, and so when we started with a quarter circle, that was easy, but if you have some other angle, well, that's how much of the circle you've got out of the full 360. Okay, the 360 is the full circle, and out of that, you've got some piece of it, some angle. That's the theta there. Okay, all right, same ideas can be used to work out the perimeter, okay? Because if you look at, we'll use the same sector, so 5 and 50 degrees, right? Now this, there's two parts to this, right? One part is the curvy bit, the curvy arc, and the other part is the two straight sections, and you've got to treat them a bit differently. Okay, we'll start with the hard bit, we'll start with the arc, right? That's how much of the circle we've got. Again, it's not the whole circle, it's a little piece of circle, and it's that much out of the whole thing, right? And so what's the length of the arc then? Well, the length of the arc must be 2 pi times 5, which is the length around the whole circle. That's the circumference, 2 pi times radius, right? But we don't have the whole circle, we've only got the fraction of it. What's the fraction again? It's 50 degrees out of 360 in total. And so we have 2 pi multiplied by the radius of 5, multiplied by the fraction 50 degrees out of the whole 360 degrees. Okay, and so we work out what that is, we get 4.36 or something like that. Okay, all right, so that's one part. The other part is the two straight bits there, but they are both radii of the circle, so they're both 5, and 5 plus 5 is 10. That's the easy bit. Okay, so don't miss them. Most common mistake is just forgetting about them because they're very easy to calculate, but just don't forget about them. Because now once you've got the straight bits and the curvy arc bit, the perimeter is just adding up those two things together, so you plus them, and you get 14.36 in this case. Okay. All right, so in general then, what's the perimeter of a sector? The perimeter is very similar. It's where you get 2 pi r, which is the circumference, the length around the whole circle, and you don't take the whole thing, we take just a fraction of it, theta over 360, and then you plus on the two straight bits. So it's pretty much the same components as we had for area, except this time we also have to remember that there's 2 straight bits to add up afterwards. Okay, and so that's how you work out the perimeter of a sector. Thanks for watching. See you later.